Okay, section 9.1, video 4. Here we're going to do a different kind of transformation. We want to do reflections. Reflection in the x-axis and reflection in the y-axis. And you have to know which one is which. Okay? So that's what this is about. Reflection in the axes. So if I take a function g of x, I take a function f of x and I take the opposite of the output, that's the opposite of y, then I get a new function g of x that is going to be a reflection in the x-axis. So if the original graph of f, if you drew that, and then you graph g of x equals the opposite of x, opposite sign, then that will reflect it in the x-axis. So it turns it upside down. Kind of like if you had y equals x squared, then y equals negative x squared is upside down, right? Is an upside down parabola. It flipped it, it reflected it in the x-axis. It flipped it upside down with the vertex staying in the same place because it was at the origin to begin with, right? Now, that's if you take the opposite of the outputs, which is y, right? What we usually call y. Now, if you take the opposite of the input, opposite of x, right? Then what that does, opposite sign of x, what that does is it reflects in the y-axis. So you're thinking of things moving, reflecting the parts that are moving left and right when you do the reflection, they're moving in the x direction, right? When you do the minus x. With the first one, minus y, the things that are moving in the y direction. So you're flipping vertically, right? So that's reflection in the x-axis, okay? You have to try to keep those straight because they might say reflect. What is the graph if you reflect this in the x-axis? And you have to know which way you're going, okay? You're changing if you're reflecting the x-axis, you're changing the y values and vice versa. So graph of f is reflected in the y-axis to obtain the graph of h. So here's my, let's just say that this is f of x, y equals f of x. And I'm not pointing at anything. That's the actual graph there. It's just a demonstration graph. It's 2 line segments. And I should have put dots at the end because I intend that it actually ends there. Okay. This is what g of x would be. So I'm just taking the opposite of fx. So say if y had a formula x squared plus 1, then if that was f of x, then g of x would be negative, what did I say? X squared, negative x squared minus 1. You would take the opposite of each term, right? So that flips it upside down. It makes all the y values the opposite of the original y value. So if this was height 1 here, this would be height minus 1. If this was at 2, height 2, right, 2, then this would be minus 2. But the same value of x, right? Okay, this one, you're reflecting the original y equals f of x across the y-axis by changing x, right? Things are moving in the x direction when you do that reflection. So you're changing the x, you're putting a minus in front of the x. So everywhere there's an x in your formula for f, you would replace the x with a negative x. Okay? And be careful if you're squaring it or taking the 4th power, you have to square the negative as well. So it's minus x is replacing x. It's a substitution. Okay? Now, there's one other quadrant I could end up in here, which is the 3rd quadrant, right? First, second, third, fourth quadrant. So how would I have this thing end up down here? Well, down here you'd be doing both reflections. You'd take this and reflect it this way, then reflect it this way. Or you could reflect it this way and then reflect it this way. It actually turns out looking exactly the same either way. So this one is, you take the opposite of the y's, which is f of x, and you take the opposite of the x's, which is opposite of x, negative x. Okay, and I'm just calling that k of x. That's what I'm calling that formula. So I have a f of x, a g of x, an h of x, and a k of x, 4 different functions. And I'm just using that function notation because otherwise I would be writing y for all of them, which I did as well. And they're different y's. I put them in different colors to make that a little more obvious. They're different y's, but it's the same x. Notice the x is always this pink color. So the original things were in pink. Remember the f of x. The output is f of x as pink, and the input is x, it's pink, right? Here, the input is the same, it's pink. The output, g of x, that's this orange color, right? And I did that with all of these, okay? So this y corresponds to k of x, which is the same thing as the opposite of the original y evaluated at the opposite of the original x. Okay, hope that's comprehensible. Sometimes people get a little confused about these things. That's what, like, because we're using x to mean the same thing all the way through, but we're using y to mean 4 different things here. Sorry, I hit the wrong button here.